Hello, my name's Dave Melton. I'm the originator of the Firetrace system. It's the world's simplest extinguisher system. All it is a bendy plastic pipe that bursts when it gets hot. The reason it bursts is because there's pressure inside it. The pressure is delivered from a small cylinder of extinguishing gas. So it doesn't matter how long the tube is or how big the can is, all the contents will come out at the hottest place because the tube only bursts at the hottest place. Now this may sound ridiculous, but the hottest place is near the fire, which just happens to be where you want the extinguisher to be delivered. Now this makes it ideal for electrical cabinets, switchgear or any other enclosures, because you can have multiple cabinets, small compartments within cabinets. The tube can be threaded through them all, but it will only burst in the section that's on fire. So the canister only needs to have enough extinguishant for the largest cabinet within the suite of cabinets you're protecting. The other huge advantage is it's power free. There's no electricity, there's no need for batteries, it doesn't have to be wired into the mains, it is pneumatic. All the energy is stored within the canister. It is that simple. You fit and forget. It's a matter of keeping an eye on the contents gauge. It can have a pressure switch added to give a warning, electrical warning, to shut down plant. There's several add-ons, but none of them are the extinguishant dependent on. It's dependent on the walls of the tube bursting. All that happens is when it gets hot, the walls soften, the internal pressure blows a bubble on the side which bursts, releasing the contents. It is unbelievably simple. One of the other causes of fire within electrical cabinets is cables coming loose because of vibration. Now it sounds ridiculous. Why do you have vibration in an electrical cabinet? Well, if you think about it, electricity, the mains electricity is alternating current, AC, so it is effectively switching on and off, and it's moving. It causes vibration. Think about it. Have you got an old strip light that you can hear hum from the transformer? Have you walked past a transformer with somebody welding? You can hear a hum. That's the mains hum. That is vibration. Now that mains cable vibration will cause the contacts to come loose, the screws to come undone. I know it sounds fanciful that vibration would cause a screw to undo, so I've done a little experiment to see why. Our electricity comes looping down the line at 50 cycles. So what I've got is a nut on a piece of studding, and I needed to produce 50 cycles to see if vibration will cause the nut to rotate. So I've taken another piece of studding, sliding it across will make a vibration. I don't know if you can see, but that vibration causes the nut to turn. So this vibration within an electrical cabinet could cause the cables to come loose. When a cable comes loose, it goes high resistance, it gets hot, or it could arc. Now, this scenario will also happen in a machine with vibration. So what I have here is a tiny electric motor with a cable clamp to make it unbalanced and a loose nut on a stud that's not connected to it. If I plug a small battery into it to make the electric motor run, the vibration will cause the nut to work its way up the bolt. I know that seems ridiculously simple, but there is no connection. That nut is completely free running, and the motor nearly causes vibration. You can see this makes any machine electrically insecure. It can be protected with a bendy plastic pipe that bursts when it gets hot. But I don't like to think of it as something quite that simple. This stupid bendy plastic pipe that bursts when it gets hot, I prefer to know as a super intelligent lineal detection system of such infinite complexity it will fit precisely to any contour and deliver its contents at the point of initiation, whilst disarmingly looking like a stupid bendy plastic pipe that bursts when it gets hot. It's difficult to take this serious, but small fires are big risks. Every fire must start small. How do you light a big fire? You start with a small one, and it gets bigger and bigger. Seems logic to me that if you put out small fires, you don't have big fires. So you have to identify the potential start point, and it needs to be where there's energy. Where there's energy tends to be dangerous, so it's in an enclosure. So look inside the box. That is where the big fire risk is. It's only a small fire, but it gets bigger. The way I describe it is, having a small fire is like being slightly pregnant. It's going to get a lot worse. And sadly, there is no morning after pill. Thank you.